Thank you so much. Thank you so much for everybody who's organizing these events, the deans and the presidents who are here, and really coming here when you have such a competing event of the Patriots Parade. I know the food here is much better, but I do want to make one reflection. Old Belichick and his wisdom outsmarted the 33-year-old coach. There's something with aging that we need to enhance and not prevent. And I really think that Ellen Baltnovic has the wisdom to take those young people, and I think that this is the really biggest Super Bowl that we're going to have, this wisdom of yours and the innovation of those people. So thank you very much for thinking like that. So if you're thinking that I'm not optimistic, let me bring you to my world. And it's a business story, insurance business story. This 100-year-old gentleman goes into life insurance and he wants life insurance. And the clerk looks at him and says, we're not giving life insurance to 100 years old. And he said, no, that's not true because my mother is insured here. He said, your mother is insured? How old is your mother? He said, she's 120 and she's fine. So the clerk thinks better, they go and they discuss and they think it's a marketing opportunity and they come to the old gentleman and say, you know what, we'll give you life insurance. In fact, if you come on Tuesday, we'll have all the papers ready. And the gentleman says, I'm sorry, I'm busy on Tuesday. And they say, old gentleman, what are you doing on Tuesday? He said, it happens that on Tuesday, my grandfather is getting married. How old is your grandfather? He said, 150. 150 and wants to get married? He said, he doesn't want to, but his parents puts lots of pressure on him. When I started telling this story, which is about 20 years ago, I ended at the grandfather getting married. And now I'm so optimistic that I had to put the parents into this story. I want to introduce you the Kahn family. And the Kahns are 4 siblings born to 2 parents between 1910 and 1920 in New York. And the important thing about the Kahn family that all past the age of 102. Okay, Helen on the left was 110, and the 2 brothers 107, 109, and on the right the little sister that died at 102, and they were shocked that she died. What are the chances, and what is about this family that their aging has been so much delayed? And this is studies that George is doing. Those are studies that I've been doing. And let me tell you, Helen Kahn, who's the 110-year-old woman, she smoked for over 90 years, 2 packs a day, okay? So first of all, if you smoke for 90 years, you're going to live long life. But the point is, they were, and all my centenarians have been resilient to a lot of the effect of the environment and that we shouldn't do. So it's a very special population. But before I'll tell you some more about that, I want to bring, by the way, some of the figures here I knew you'll see before. I was counting on that you'll see before, and so I'll bring them with a little different aspects. But I'm seconding everything you heard before. But I thought this is in a business school, this is a nice graph to have because you notice that there's a log score there, okay? Imagine that you have an investment that went from 5 to 5,000, like heart disease when you get old. This is a pretty good investment. But the risk of disease by age is really, really very high. And it's the risk of aging for heart disease or for cancer, the parallel line there, or for diabetes or for Alzheimer is much greater than, for example, cholesterol for heart disease that is only a 3-fold, or obesity for diabetes that is only 5-fold. The major risk for age-related disease is aging. And so when we looked at this graph before, that's what I saw when I came to get grants at the NIA. The thought was that we are not going to make much progress unless we target aging. Because suppose you're going to be successful in eliminating one disease. When you get the other diseases, I mean, what happens when you walk into the emergency room with a heart attack now? You get a stent or you get a bypass. That's a local treatment to the heart. And those people, within 2-3 years, have high risk of getting Alzheimer's, cancer, and diabetes because all you did was treated the heart and not the major risk for those diseases with this aging. And what we found, beside the fact that aging is a major risk for all age-related disease, is we actually proved that aging drives those diseases. And I want to make two important statements. First of all, yeah, there is genetics for other disease. We know that we have genetics for other disease. And I think that will decide what you're getting first. If your mother has diabetes and you're obese, you're going to get diabetes first. But the other diseases of aging will be coming on because they accumulate rapidly after the age of 60. The second point that I want to make, and you know probably by looking at your friends or your parents, that the chronological and biological age are not the same. Okay, people are younger than their age and older than their age. And this is kind of why I went to look at centenarians where obviously their aging would be delayed. And you've seen those slides on the hallmark of aging. This is the European one, has 9 pillars. With Brexit, they're losing 2, I hear. And this is the American one that have 7. But please concentrate on the American one and the network in between. And I think this is very important. I'll give an example. I wondered what examples you were going to give. I'll give an example that you haven't heard yet. Ana Maria Cuervo at Einstein is an expert on proteostasis, or more correctly, she's an expert on autophagy. And autophagy is the garbage cleaning mechanism in our cells. It's actually a green energy garbage disposal mechanism. And Ana Maria Cuervo, with genetic methods and with drugs, have been able to increase the clearance of garbage in our cells. She prevented and cured Parkinson in models and Alzheimer in models because the neurons are really accumulating this beta protein and they're really freaking out from this dimension. But the important point here is then when she does that, she affects also the stem cells, the metabolism, and the inflammation. And that's common to a lot of the drugs that we're testing. They're supposedly we're targeting one thing, but because of the connectivity, we're influencing other. We still want to have enough tools for everyone, but we can start making a lot of difference by starting even with one aspect of that. And I would summarize what we've done and what you've heard before, that healthy lifespan, and I want to say that it's healthy lifespan. What we're trying to achieve is health span. In my mind, longevity, with the commercial, you'll be healthier. The side effect, you'll have longevity. Can you pay for it, I think longevity is a side effect, but we can target health span, and we've targeted health span in many models. We can do it in nematodes and in flies and in mice and in rats and in monkeys, and we can do it by interaction with the environment or genetic manipulation or drugs. And really the most important thing that some of those drugs are actually in human use. And I would say the following: since our maximal life expectancy, we think, is about 115, right? There's somebody who lived to be 122. But it's about 115, and since we die now before the age of 80, there's 35 years potential, without changing our body in any substantial way, that we could realize now and allow George to move on can we extend it below or can we make it better, but there's a way to move right now. I also should mention that the NIA had this intervention testing program, and it's just to show you some of those drugs that are given to animals and the control in 3 different centers. And the animals that are kind of shifting to the right are those who are surviving longer. And there are few points to realize here. First of all, that a lot of those drugs are extending lifespan. On the bottom right, the combination of rapamycin and metformin has the world record in longevity of 24%, increase in health span and in lifespan, and much more that in health span. Also, you notice by the rapamycin, and there's an error there on the bottom middle, you can target aging later in life and still get an effect. It's never too late to target aging. I bet the senolytics that you heard about from the director is something that you target later in life because you need to have more senescent cells. And maybe some other intervention, actually like the one George mentioned, you have to start earlier in life, and we'll have to figure that out. But there are examples of drugs that improve health span and longevity. Now back to humans, and I told you that chronological and biological age are not the same. This is a study looking at centenarians around Boston and centenarians around New York. I'll talk about the green and blue, which are my centenarians. The green is control. It's people who don't have longevity in their family. And the blue is the centenarians that I'm looking at. And the question we ask here has nothing to do with their longevity, but with their health span. The curves doesn't show how much they live, but how much they live free of diseases. And you see in the green that after age 60, those guys, our control, are starting to get sick. And at age 80, maybe 10% of them don't have a disease. But you can also see in the blue, in the centenarians, that their health span is increased by 20, 30 years. And even after the age of 100, 30% of them don't have a disease. Though this is an example of people who are living now, and it shows you that, yes, as a species, we can increase our health span dramatically. But that's even not what excites me about people. What excites me is they die without being sick or with very short morbidity time. They have a contraction of their morbidity. So if we spend 5, 8 years sick at the end of our life, they spend weeks or months, or sometimes they just don't wake up in the morning. And this actually has been monitored by the CDC out of Atlanta. This is a slide from '93, and it repeats itself since then. The last 2 years, the medical cost in the last 2 years of somebody who dies above 100 to those who dies at 70 is third the cost. And when those 100 years old were 70 years old, they even didn't go to the doctor because that's not what they used to do there. So those data that suggest that we have ability to live healthy and to have contraction of morbidity, and it will have an economic impact, has been translated to what we call now the longevity dividend. The longevity dividend is the saving of trillions of dollars by expanding our health span by even 2-3 years. Let me skip that. So what are the challenges to translate our advance in understanding aging to humans? So this is the challenge. In every other disease, you find the biology, and you have biotechs and pharmaceuticals, and you develop drugs. And the drugs are targeting the disease. And you actually come back to the scientists and said, you know, we're running out of patent. Maybe there's another mechanism when maybe we'll do another drug, and everybody is happy with those diseases. For aging, the FDA doesn't have an indication to target aging. And we feel, and when I say we were a bunch of scientists, that we feel this is the one that's holding us most. And why is it holding us? Because if there's no indication, the healthcare providers do not pay for their clients. If they don't pay for their clients, then the pharmaceuticals are not going to do those better drugs, other drugs, because they have to have a business plan. So for us, the major obstacle has been the FDA. And we, against a bunch of scientists, found a way to deal with it. We took a drug by the name of metformin that extends health span and lifespan in animals. We understand a lot of the biology of that. Metformin is a first line for type 2 diabetes. It's generic, very cheap drug. It's one of the cheapest drugs in the market. And we have 60 years experience and outstanding safety record. I'll show you just one data that really makes a case for everything I'll show you next. This is a study outside of England because it cannot be done in the United States. You can go to the pharmacies and choose patients and somehow look at what happens to them, in this case, mortality. And there are 200,000 people in this study. They took in blue people with diabetes that got another drug, sulfonylurea, and as expected, with sulfonylurea, the mortality, what you see is mortality, okay, the survival really. You see that there was more mortality in diabetes, we know that. They were controlled with the red group that were in the same pharmacies, treated by the same doctors with the same kind of diseases, so was significantly decreased. Then they took 78,000 people who were put on metformin and compared them to 78,000 people, same pharmacy, same doctors, who don't have diabetes. The people on metformin, although they had diabetes, they were more obese to start with, they had more disease to do with, lived 17% significantly longer than the people without diabetes. So if you wanted to see that metformin is really related to aging and longevity, we have that. But that's not the only thing we have. We have intervention, and when I say intervention, it's clinical studies. And let me join the choir here of, when you ask what you do, well, you can do something if there was a clinical study, if there was intervention study, if there was a controlled study, a double-blind study that showed that something was better than another. Otherwise, it might be good, but you don't know. So there's already intervention studies to show that metformin delays diabetes. There were already intervention studies to show in another population that metformin delays cardiovascular disease. There's association studies, so that's not as strong, but hundreds of association studies to say that people on metformin do not get cancers. The NCI is supporting 200 studies with metformin. There's intervention study to support that the cognitive decline in Alzheimer has been delayed by metformin, and I just showed you the other study. And that's why we said, metformin is a tool to show that we can target aging. So what did we do? We have a study that's called Target Aging with Metformin. By the way, it's going to start soon. And we have really, one thing is, of course, to prove the concept. But the other one is to really speak with the FDA. We're a bunch of scientists going to the FDA and saying, we have a drug that, according to the geroscience hypothesis, will target the biology of aging and prevent disease. How do we do that? And I want to stop and show you, out of National Geographic, breakthrough episodes that were done by Ron Howard. It's the best film that was done on aging. A really great film. I suggest you see that. It was produced and narrated by him. But he covers our excursion to the FDA, where he basically says that's how breakthrough looks like. Can we please have, this is a three-minute film, and then I'll wrap up the... I want to make several points in closing. the TAME study is agnostic to what disease you have and what disease you're going to get. Every disease gets a point because our hypothesis is that we're intervention with aging. We don't know what's your next disease. It's a cluster of diseases. It's exemplified here where if you have major cognitive function, what's the rate of you getting the other diseases? It's the same if you have now cancer and getting the other diseases or CVD and getting the other diseases. It really doesn't matter. The second point is we're recruiting people between 65 and 80 years old because that's the age where there's a lot of happening. Now, people in the industry that are looking at one disease says 3,000 people, that's very few. And it is very few for one disease. But if we cluster the diseases together, we need less people. And this is important because this is template for every one of you that want to do, to see if you have something against aging. It's not like the 12,000 people that you need for phase 3 in diabetes. And the outcome, the primary outcome, which is the FDA outcome, is really time to incidence of many age-related diseases. And each one of them counts. I'll skip that. So what we're trying to do is, while there's accelerating after the age of 60, there's acceleration in the number of diseases you accumulate and the treatments and their side effects and their interaction, we hope just to start flattening the aging significantly. The last points I want to make is, yeah, this is my conflict, COBAR, but let me say just one thing. When we went through COBAR, we didn't have the perspective that there'll be indication to aging. And really what everybody in the aging biotech is trying to do is find indications on the way to aging. It's not always easy, but we're trying to do that. And I'll show you some of the life bioscience, but this is the consideration that you guys have to have. When you have pharma, they have extended time horizon and they're trying to decrease the risk. And with venture capitals, they need to be done in 2, 3, 4 years, but they are ready to increase the risk. And for aging, we need a new model, okay? We need to understand that the horizon is, the time horizon is not there, and that you have to have a bigger investment. And I think that's what the biotechs and venture in the field are thinking now. And there's a lot of them. I'm not going to tell you what, but there's a lot of them, and they have pretty impressive valuation. We need everybody to do aging. We haven't convinced everybody to do aging, but at least the biotechs are starting to do that. Life bioscience is targeting all the aspects of aging, okay? We're trying to target everything that's possible so that eventually we can have maybe several drugs or drugs that you take together in order to do that. But also to say that life bioscience has approaches that are relevant only for aging. We have daughter companies that are dependent on us on many ways, but one big example is we have labs that have aging animals. A lot of the studies for age-related disease in the past have been done on 2, 3 months old animals. Genetic manipulated. It was the wrong template, and no wonder that so much has failed. You have to show in aging animals, on the biology of aging, on that platform, if things are important or not. So those are part of the consideration we have. The future, okay, is very important. George started talking about it, but think about it. A sperm of a 70-year-old person and an egg of a 50-year-old woman, okay? They can meet and form a blastocyte. And although the sperm and egg have an age that you can actually monitor epigenetically, When they form this blastocyte, it's erased. They start at zero. We actually figured out how to do it in our body. We just need to make sure that this erasement of aging is something that is in our power in the future. So aging can be targeted. There are strategies. There's a TAME study that will change the regulation, and there's a lot of biotechs that are happening now. And I'm done. You can read The Time in the Bottle and think of it as alternative to really extending health span. Thank you so much.